Kia ora, folks, and welcome to COVID Chat with me, Dr. Siouxsie Wiles. I'm a microbiologist and associate professor at the University of Auckland. And I'm here Mondays, Wednesdays, and Fridays around about this time to talk about some of the science behind COVID-19 and what's happening in the science world. Let me introduce you to Damien Christie from the Aotearoa Science Agency, who's the brains behind this whole thing. Hi, Damien.
I don't know if I like being called the brains behind it when you're sitting there, Siouxsie, but yeah, I'll take that. Good afternoon. Happy Easter weekend still, everyone. I hope everyone is enjoying the long weekend. And it seems like a very strange Easter, doesn't it? Siouxsie, so I thought, yeah, today we're going to have a look at some, because our email box has just been inundated with questions, and a lot of people are saying, have you seen this study or this study, or have you read about this or that, or does do essential oils work, does drinking chlorinated water work, what about this study from 2014 on a different coronavirus, things like that. So and in our discussions off air, a few of us have been sending you stuff, and you said, oh, actually, no, this one's bad. So I thought we'd take an opportunity to look at the science behind some of these things, for better or for worse. Anyone who's got questions throughout the show, send them to nzcovid@gmail.com, nzcovid@gmail.com. But as we like to do, Siouxsie, should we start off by looking at the daily figures?
Yeah, and another sad day today with another death announced by our Director General of Health. But also we had the announcement of 19 new cases today. So another nice low number coming after 18 yesterday. So this is we like the look of this curve very much. I guess less tests were carried out because of the long weekend and the Easter weekend. So I guess we'll see what happens in the next few days, but hopefully the cases will stay that low. But as I have explained before, we should expect the numbers of deaths still to rise. And this is especially true because there are several clusters now that involved aged care facilities. And we know that those people in the aged care facilities are much more just going to have an awful ride of this virus. So our thoughts go out to their friends and family. It must be a very difficult time for them. In terms of what this brings our total to, so 1,349 cases. Yeah, so we're definitely not on exponential growth anymore, which is fantastic. My worry, though, is that everybody is now yelling for us to come out of lockdown early. What would happen if we did come out of lockdown early is we'd likely see the cases start to rise again. So we just need to be patient. I know that this is hard for lots and lots of people, but if we hold our nerve, then we're going to really see the benefit of that. Whereas if we come out too early, then it will feel a little bit like this was all for waste, really. In terms of the worldwide situation, it just keeps rising and rising. I mean, so many countries are really not able to get a grip on this virus just yet. So we're approaching 1.9 million cases. The USA has exceeded now 500,000 cases. And the reports we're hearing about the numbers of deaths it's horrendous. And this is exactly why we are all in our bubbles here, trying to minimize the number of people who are going to die from this virus. Okay, so let's talk about today's big topic, bad science and how to spot it, what studies to believe. Oh my goodness, this is such a big and hard thing to talk about because in many respects it's almost an impossible task to spot quite a lot of bad science because the people who do bad science can go to quite extraordinary lengths to make it look like good science. So we used to have some really, like kind of easy rules, like has it been published in a peer-reviewed journal, which means that, a whole bunch of people have critiqued it. I'm really sad to say that at the moment there's such, I guess there's so much work being done around COVID-19 that so many people are pushed trying to get these papers out. that there are some terrible, terrible science is being published after peer review in really prestigious journals. So you can't use that as a measure anymore. And on the other hand, there are some incredible studies that seem to be coming out on what we call preprint servers. So these they might be under review at a journal at the moment, but on its preprint form, it hasn't been peer reviewed. So we can't really even use that as oh, don't look at those studies and look at the other ones instead. I guess that as a scientist myself, what I have built up over years is the skill set of being able to look at a study and look at how it was designed and what it's doing and try and make some judgments around that. That's a really difficult skill to teach you in just a few minutes, I guess. But also one of the things that I do in studies that are not in my area, which is lots of things at the moment, is I go and look for what the experts in that particular field are saying about it. And that's actually, lots of them are on Twitter and social media or have blogs. And so you can often find things related to particular papers if you look for them. But that's the thing, is you have to be able to look for them. So I would just be mindful of, what you're looking at. I think one thing you can do is look at who the study is done by. So at the moment, there are lots and lots of people who are jumping on the COVID-19 bandwagon and publishing studies that are completely out of their area of expertise. Now, this isn't necessarily a bad thing, because sometimes having, a perspective from somebody out of the area can be really valuable. But what I would expect is that those people would be collaborating with actual experts in the field in order to get the best of both worlds. And so I'll talk a little bit about this in a minute in relation to a question that one of our listeners have or viewers have asked. But I wanted to highlight this with really just talking a little bit about lots of the studies that you're going to see coming up are around trials for treatments. And so one of those has been published just recently, and it was basically suggesting that one of the treatments that's being tried is looking really successful. And I want to just show you how shit a study it was, basically. And so these are the sorts of things that you could be looking for when looking at these particular type of studies. So this one appeared in a very prestigious medical journal, and it was about using this drug called remdesivir to treat COVID-19 patients. So the gold standard that you're looking for a drug trial is what's called a randomized placebo-controlled trial. So the idea is that a group of patients are taken and randomly allocated to either receive the treatment or to receive a placebo. And generally, this should be a kind of blinded thing where the patients or the people treating them don't know who gets the treatment. In a good trial, there will be a whole bunch of parameters set, like what are the conditions that will mean that a patient is enrolled in the trial, and these are all transparent. And then, and what are the reasons why maybe a patient shouldn't be enrolled? And that might be because there's perhaps some underlying health issues that they know might mean they might react badly to the drugs or something. So we understand why patients are excluded from the trial. And then a trial generally has a point at which a decision is made about what outcomes they're looking for, and then they can compare between the patients that had the drug and didn't have the drug. Okay, so that's what we are looking for. And while it may sound difficult to do in the middle of a pandemic, it's not difficult to do. It is actually, this is the time when we should be doing proper trials rather than just chucking drugs at people and hoping they might work, because we really do need to know, do they work? Okay, so this trial basically wasn't a trial at all. So the company that owns the drug got to decide who took the drug. Lots and lots of people were applying to be patients in this trial, and the company, and so there would have been thousands of those, and the company basically got to decide. And this particular paper documents what happens to 61 of them. So that's a very small number of people compared to, we have 1.9 million cases. So 61 is a small number of people. And so we don't know how those 61 people were chosen. There's nothing about that. When you look at it, though, it might seem that the ones who got these drugs were ones that were more likely to survive, and that's a big red flag. You know, if you're kind of biasing the way the trial might actually work. So it certainly looked like about half of their patients were going to do okay, regardless of whether they got the drug or not. And then of those who had a worse infection, actually, some of them still died. And in fact, the drug well, they say about half of the people improved. But the problem is we don't know whether that same, you know, people who didn't get the drug, if half of them would have improved or some of them would have died either. So we have nothing to compare it against. And quite a lot of people didn't finish the study. So they started with 61, but they didn't finish with 61. So quite a lot of people were either excluded or stopped taking the drug. And we don't know what happened to them, so they don't report that. Again, that's something really important that should be reported in a trial. And sometimes people stop trials because they're having such terrible side effects with the drugs that actually they pull out. And that's a really important thing to know if this drug is going to be offered to, you know, potentially millions of people. So the things, and then there's another really big red flag was that despite having over 50 doctors as authors on the paper, so the trial was designed and paid for by the drug company, and then one of their writers wrote the first draft of the manuscript, which suggests that they actually wanted to decide how the study was portrayed. That is a big red flag, because there should have been plenty of doctors within those 50 who could have written the study up. Okay, so things for trials are how many patients and how were they selected? Is there a control group? If there isn't, why? What happened to the patients? Did any drop out? Those are all really, really important things. And based on that, I would say this study tells us nothing about remdesivir and whether it's going to be useful for COVID-19. And with that, let's bring Damien back and we'll get on to your questions.
Yeah. Okay. Thank you, Siouxsie. I hope that, are there any, I mean, that's the amount of information you need to be able to look at a study like that and work out whether it's good and bad. Are there any, is there anything that people out there can do themselves? I mean, for me, you know, the starting point, as you say, it used to be, is it in a good journal or not? As opposed to some sort of random website that says, you know, stopthe-COVID-19scam.org or something like that, which is usually a bit of a red flag in itself
Well,
about the science.
That is a red flag still, yeah. I would say. Yeah,
are there any
simple
certainly tips?
You know, there are things where you can say, you know, is this even plausible, whether something would work? But I think that this is just, it's becoming so hard, and for some people who don't have much basic science knowledge at all, I think it's just very, very difficult to say. And so that's why I think look at who is talking about studies, writing about studies, and what's their background and what's their expertise. That's who I would trust. Yeah.
Do you think there's also a bit of a case of sort of armchair referees at the moment? Everyone's trying to be on top of the science. Everyone's looking out for someone who missed something as the government dropped the ball on this. Has the scientific community even heard about this study that I've found on the internet? Do you think maybe people should just kind of back off or relax a little bit, perhaps?
Don't. Well, and also because, yeah, I mean, we certainly saw this in the early days, and I guess we still see it now when somebody say, well, I found this study about coronaviruses from 20 years ago or 5 years ago. And it's like, well, you do have to remember that the coronaviruses are a big family of viruses, and you know, humans have had them for a long time. Many of them cause the common cold. And then, of course, there are these very important ones, the ones that cause SARS, MERS, and now COVID-19. So there will be lots of studies on, you know, similar or on coronaviruses, and that doesn't mean they have any relevance at all to this particular coronavirus.
Very good, thank you. On to the questions then, and so we've got one that's just come in from Nikki via the Facebook, and it links in to one of our other questions. Nikki asks, do you think there should be random community testing across New Zealand? I know that's something that you've talked about, and the question from Forrest as well, how many New Zealanders do you think are infected beyond those who have been tested? They're sort of linked to.
Yeah, so these are really difficult questions, and ideally we would be doing lots of random testing to find out whether people had the virus or not. Now that we've been in isolation, lockdown for a couple of weeks, that number should be dropping. I guess it's also a very hard number to come at. So without doing this, what we call these sort of like prevalence studies. So some of the modeling has suggested that maybe for every case that and I use we as humans, not we in New Zealand, but for every case that's known about, there are either 1, 5, or 10 other cases that we don't know about. And obviously, the more people there are spreading the disease around, then the likelier and the higher that number might be. So because we've all been in lockdown for, what are we now, 19 days or something, we would hope that number is very low. One of the things that I have seen talked about a lot is this. So Iceland was a country that started doing this random testing. So actually, they did 2 types of testing. So they can do this because they have a company in Iceland that does a lot of genetic tests and things. And so what they did is they had 2 types of testing being performed. So one of the university hospitals was testing suspected COVID-19 patients and contacts. And then they basically anybody could turn up at this place and say, I want to be tested for COVID-19. And so they, of the people who just turned up, I got some figures just from the other day. So 6,163 people turned up to be tested, and only 52 of those were positive. And so one of the ways this was then reported in the news was that so they didn't give you those numbers at all. They just said half of people who got tested in Iceland were positive, or half of people without or didn't have symptoms or something. It was really, really misleadingly reported. And what I just want to say is that there were 52 positives. And I went back, the only place I can find anything written about them is on the Icelandic kind of Ministry of Health equivalence website, where they give the numbers and they say that people who turned up for testing also included people with mild symptoms. So it's really unclear actually how many people who had symptoms tested positive versus didn't have symptoms, and what that generally means for the public. But that gives us a prevalence of 0.008%. So if we plug those numbers into New Zealand now, that would be about 40,000 people. But the point is, we have all been in isolation, more or less, for 19 days. So we should have nothing like that number. But it's a very hard one to get a hold on. And what would be ideal, I guess, would be to start randomly testing people. But the question is, how many people do you have to test in order to get a representative sample of people and to get you a number? And that's the sort of thing that some statisticians are all basically arguing about at the moment, because if you don't want to test too little to get where you don't get the answer. But we also obviously have a limited resource that has to be used wisely, especially if we're going to come out of lockdown and we might have cases. So it's a bit more complicated than just, let's swab everyone, because actually we don't have enough tests to swab everybody, basically.
Okay, I think the answer to this next question might be a bit shorter than the answer to that very difficult first question. This next question is, where are we? From Bob. Can the New Zealand testing regime urgently be expanded to include pets, cats and dogs, etc., of those households that have been tested positive for COVID-19? If not, why not?
No. Yeah, so actually, and this is not just about the using the tests for looking at animals versus humans when we need them for humans, but actually, so remember I said coronaviruses are a family of viruses, and so it's not just humans who get this family of viruses. And so this test has not been validated against use in animals, and whether animals have coronaviruses just naturally, that would pop up a positive result. So that's something where the test would actually have to be validated properly against those things. So there are animals that have been tested, but I think if you rolled it out, that you may well end up having results that you either didn't understand or that weren't actually reflecting what is happening, if that makes sense.
Question from Beck: if we can transfer the virus from our hands to our face, should we be washing our face more?
Well, I mean, the whole point is that if you touch your mouth or your nose or your eyes, then you get it into your body. Sure, wash your face and your hands, that's fine. But as long as you're washing your hands too, because that's what's picking it up from other places.
I did see one question actually, which I haven't put in the list yet, but was saying that given that most soaps and soap detergents and things like that don't have antiviral or antibiotic properties, to antibacterial properties to them, how do they work? How do they actually get rid of the virus?
Oh, well, that's just to do with well, there's two aspects to it. So the one is just the physical washing of things and removing stuff from your body and having it then go down the tap. But the other is actually just soap is awesome. And soap has this property of basically kind of finding fat and then kind of sticking to it and bursting it. And because this coronavirus is what's called an enveloped virus, it's highly likely that the soap also actually is able to destroy the envelope of the virus, which is why soap is better than hand sanitizer.
There you go. A question from Fiona. I've read that there are variously 8, 2, and 3 different strains of coronavirus, with different parts of the world suffering different strains. Do we know which one New Zealand mostly has?
Yeah, so I'm really glad you brought this up, because this allows me to talk about another bit of really bad science, which is slightly different to the first bit of bad science. And that's that a paper got published, again, in a very prestigious journal just a few days ago, suggesting that there were 3 types of this coronavirus, and their proposal, I believe, is that it's kind of now adapting to different human populations, and they made a whole bunch of spurious things. Anyway, so again, this is where I because of my field and my interests, I know a lot of people who are interested in the genetics of, viruses and pandemics and epidemics and stuff. And so I went to see what they were saying about this, and they are all furious about this paper. So the reason this paper has sort of happened is that lots of the viruses that are being sequenced, their sequences being made available online, essentially for anybody to look at, but really for experts to look at. And so there are a whole bunch of them, and there's a really fantastic website. Actually, I'm going to find you the name of it because it's very, very cool. We were way better to look at, called nextstrain.org. And so what's really good about that is there are experts who are looking at all of these thousands of genetic sequences and building family trees of these viruses and showing how so there are small mutations happening and how that is changing kind of around the world. So this particular study was done by some people who have no expertise in this particular area. What they have done is downloaded 160 of the sequences, of the thousands of sequences that exist, and run them through a program that's basically just a pretty visualization, but isn't even the one that would be used by the experts, and then published it with some spurious kind of things. And so what the experts in this field are saying, that actually they don't know what they're talking about. The parameters they're using to build their families are completely wrong, and so you just can't say anything based, there's just nothing that they are saying is supported by any of the evidence that exists. And it's really annoying because they are all doing really, the people who are actually experts in this area are doing what's really, really good stuff, and they haven't quite published all their findings yet. And so we are going to have to wait and see, but they are all fuming about this and saying that it's completely misrepresenting what's going on. And I'm going to believe them because they are the experts. Oh, as for what's going on in New Zealand,
Question from Tony.
so I believe that
yeah.
there are plans so we have some experts in New Zealand who do this for other viruses. So Alexi Drummond is one person whose entire one of his research strands is looking at how the flu virus evolves over time and as it comes in waves and things. And so my understanding is that he is going to be working on this for New Zealand. I believe we've got, because there are these sort of there are some variants, though whether they're real, whether they actually have whether the changes in them actually make any differences in the disease people have is not at all known. Because we've had multiple introductions into New Zealand from people from different places, it's likely that we have got lots of these different variants going around. And whether there ends up being anything different about the variants and people's response to the virus will be a field of study for years to come. Understanding what did they have, which virus did they have, how did they respond, what was to do with human versus what was to do with virus thing will be something that's looked at later by actual experts.
I've got a question from Tony. We may not know the answer to this one, but I'll ask anyway. And on the geographical area where cases are identified, Tony notes that Waitemata DHB is a big district. But if there's no cluster in that district, does that mean the cases are spread all over? And is there a way to know whereabouts these cases are and whether she's safe in her particular suburb or not?
Impossible to say. I mean, I guess the DHBs will likely have that information, but given that we're all in our bubbles, we should be safe in our bubbles. And that's the important bit about us minimizing our contact with other people, is to avoid getting the infection and to avoid spreading it in case we have it without symptoms.
Very good. Given is there any research being done, this is from Kelly, into why certain people are seemingly immune or at least asymptomatic when it comes to COVID-19? Is it possible they have something in common, like a certain gene expression or mutation?
Well, humans are complicated, and these kinds of often things like they're called whole genome association studies. They're often can sort of come up with the most spurious things. So often, we have lots of genes, and when you're trying to find an association between something like disease and not disease, you can find things that are different that are just completely due to chance. And so there may be something. Again, finding it will be studies done in over the next few years. There may well be something to do with people's immune responses. But yeah, it's there's nothing that we can point at right now.
Lockdown fatigue question, this one, I think, but potentially we'll make this our last question for the day because we've gone quite over time. What is time anymore? Question from Jessica. As we have mostly been in lockdown, what is the danger of neighbours when we're all asymptomatic and we're not close contact?
I'm not sure I really understand this. I mean, so is this about being worried, or is it because I'm asking people not to meet their neighbors for wine, and because we've all been in lockdown for 19 days, it should be okay? I guess the point is, if your bubble has asymptomatic virus transmission going on, then depending on how many people are in your bubble, because of the fact that there's an incubation period before people come down with the virus, 19 days is not enough time for everybody in your bubble, if you've got 4 or 5 people in your bubble, to potentially have passed the virus around. So you could still have somebody who's infectious, and then you go and you meet somebody in another bubble and you can transmit it that way. So that's why we need, if we do this now, if we start breaking those bubbles now, then when we come out of level 4, then those cases will start popping up and we'll see exponential spread again. And so that's why we just need to, even though we've been in lockdown for all this time, we just need to hold on that little bit longer. I can't stress this enough. Like, don't mess it up now, New Zealand. We are so nearly there. It's like, don't fumble the ball. Just keep holding it. If you need a sports metaphor, that's about as far as I can go with that one, I think.
There is a question from Josie, which I think I can answer. My husband has had a dry cough for a few weeks. During the last night, he was very hot. Today, he seems to have gone into a head cold, and he has slept most of the day. Call Healthline. Call Healthline. Siouxsie is not not a medical doctor and not going to give medical advice over the internet. If your husband's been ill for a few weeks, give them a call. Do you know the 0800 number for Healthline off the top of your head? I'll find it.
Oh, I don't. But you can also just call your GP.
Yeah, 0800. Here we go. 0800 611 116. 0800 611 116. Don't wait another few weeks. Thank you very much, Siouxsie. Hey, Siouxsie, how have you been spending your Easter weekend apart from doing 2 shows?
Yeah, reading papers, working on another graphic with Toby Morris. Yeah, haven't really done huge amounts of relaxing. bit naughty. Did
Plenty of
play a
time for
board
that
game
when we get
yesterday,
to-
though.
Good. Very good. All right. I thought this is we'll just if you do have questions, we'll be back on Wednesday. If you do have questions, nzcovid@gmail.com is our email address. We've got heaps there. Sorry we can't get through all of them. I will reply to some of them personally as well. And really appreciate everyone watching. Appreciate you giving us your time again, Siouxsie. I thought I'd end with just another one of those little bits of genius that people have been coming up with, trying to fill in the weeks in lockdown. This is a video from a chap who's obviously got some quite talents on the voiceovers. See you guys soon.
Final minute and Olive in possession, but this is where Mabel is strong, chasing the game, using that intensity. We saw it in the semi-final, staring at a slightly torn cloth rabbit for over 7.5 minutes. And perhaps a few signs of overconfidence from her rival, a bit of showboating. Needs to be careful. And there's the change from the classic hold, still placed on the outside though, great technique. And a glance at the youngster who shows little emotion, but her mind will be empty. 20 seconds to go now. Olive closing in on victory and that coveted prize of being told she's a very good dog. One paw to control and a switch. Now Mabel sensing this might be a chance, still waiting, still believing. And you wonder what Olive is doing here, only has to hold on, going to the upright though, high tariff with no opposable thumbs, high risk at this stage. And it's gone and Mabel takes it. No mercy from the younger dog, who takes this victory just as time runs out. A famous win built on patience and sheer belief. For Olive, only thoughts of what might have been, but only herself to blame. She's given this one away, and that will hurt most of all. Bad dog.
Thank you.